LeetCode coding challenge, and today we are going to solve our next problem statement, lowest common ancestor of a binary tree. Given a binary tree, find the lowest common ancestor of the two given nodes in the tree. According to the definition of LCA on Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q as a descendant, where we allow a node to be a descendant of itself. So we have given a binary tree and two values P and Q, two nodes, and we need to find the lowest common ancestor for these two nodes. So what is the lowest common ancestor? Let's find out. So for this test case, the P and Q value is 5 and 1. So this node and this node. And what is the lowest common ancestor? The lowest common ancestor is the node that the lowest node that is connecting both the node. So for the 5 and 1, there is only three node that is connecting both the node. Similarly, we can change our P and Q value. If our P value is 5 and our Q value is 0, then again the lowest common ancestor will be 3 only, because it is connecting both the node, right? Because if we take 1 is not connecting 5, right? Because the top node is 3 and we are going from top to bottom. So from bottom to top, we cannot go. We are only allowed to go from top to bottom. So for 5 and 0, the lowest common ancestor node is 3. If we take another example, 5 and 4. So remember, any node can be descendant of itself. So if we have given a 5, 5 is also a descendant of itself, and we need to find the lowest common ancestor. So 3 is connecting both 5 and 4, but it is not a lowest common ancestor. 5 itself can be a LCA of itself. So 5 is an answer for this, for 5 and 4, because 5 is connecting with itself also and with the 4 also. Similarly, for 5 and 7, the answer will remain the same, 5. For 5 and 8, the answer will be 3. And similarly for 6 and 4. For 6 and 4, the answer will be 5, because 5 is connecting both 6 and 4. So I hope you got the problem statement. Now let's discuss how can we solve this problem statement. So we have this binary tree, and we need to remember these couple of conditions to solve this problem statement. So one condition, if any point, if we reach to the leaf node of our binary tree, we will return the null. So this is one condition. Another condition is, so suppose if I take these two nodes, these subtree as a binary tree, and let's say our value of P is 0 and our value of Q is 8, right? So this is our, so let me change the color. So these are our nodes with the value of P and Q, and now we need to find the least common ancestor, lowest common ancestor. The lowest common ancestor is 1. That is connecting both 0, 0 and 8. So for this condition to solve, we have added this condition, this second condition. If our left is not equal to null and right is not equal to null, so we are going to return the head. So first condition is the leaf node will return the null, and it will only return null if during the traversal we didn't get the value of P or Q, right? So for this test case, this node will return null. And similarly, this node also will return null, and this node will also return null. And this will also at last return null. But for this, if our left side is not equal to null and our right side is not equal to null, it means we found our P and Q. So for any root, if the left side and right side is not equal to null, it means the right will be our ancestor. So for this, we will return the head here. So we will return the 1, and our 1 will be the answer. So right. So I hope you get this second condition. Now let's check our first condition. We are saying if left is equal to null, then return right, else left. So for this, our left is null and our right is 1. So it means if our left is null, we are going to return the right as an answer. So it perfectly makes sense, right? Because in the left part of our subtree, we do not have our P and the Q value. And our right part, we have the P and the Q value. So it means we have returned the answer, and if our left side is null, we simply return the right. Or if our right side is null, vice versa also. If our right side is not equal to null and left and right side is null, then we are going to return the left. So this is for the first condition. So we have covered the first condition, second condition, and fourth condition. Let's come to this third condition. And now let's change our test case also. So let's make it again black color. Now let's change the value of P to 5 and Q to 4. So this is the case where the node can be descended of itself. So the answer for this is 5, right? Because 5 is connecting with itself also and with the 4 also, right? And for this test case, the right side will returns null because we do not have the P and Q value in our right side of the binary tree. So this will return null from the right side. Wait. But we are saying if our left, if we found the if we found the our P or Q value, let's say we found the P or Q value anytime, we should return the head itself. So for this, we goes to 5, and as soon as we find our P or Q value, so here only we get our P value, so we do not need to move further down. We do not need to do further processing. As soon as we found P or Q, return the value itself. So from here only it will return the 5. And again, this first condition will execute. Here, the left is not equal to null and right is equal to null. So the answer will be 5. So this case is also get handled. One case is when our root node itself is either a P or Q. So let's discuss that case also. So for this, as soon as we go to our root value and it will satisfy our third condition, right? Our root is either equal to P or equal to Q. It will return from there only, from root itself. So it will not go do the further processing. Because as soon as we get our one value from the top, we do not need to do further processing, right? It do not make sense because every root is a descendant of itself. And as soon as we get our first node from the top, that will be our answer. Another case, and one case where we have discussed before, one node exists in our left side and one exists our right side. So that case we are handling from our second case when our left is not equal to null and right is not equal to null. And another case is when both P and Q exist either in our left side or in the right side. So that case also we have handled from our second condition or our third condition. So I hope you got the solution. Now let's do the coding part. We are saying if our root is equal to null, return null. So this is the case when we are saying if we reach to the leaf node, it means we didn't get the value of P or Q, right? Then do the DFS traversal. What is our left side? Call the lowest common ancestor. Move to the left side. Pass the P and Q node. Similarly, move to the right side also. Right. What condition we need to add? If we found P or Q value from the top itself, we return immediately at that point also only. So if our root have the value of P or Q we return there only. We do not need to do further processing. We found the lowest common ancestor. To return from top one, to return root. Now we have added this condition. Now one condition is if for this case, right, when our 0 and 8 have the when our p value was 0 and our q value was 8, so the lowest common ancestor was 1. So when our left and right is not equal to null, so if our left is not equal to null as well as our right is not equal to null, it means our left binary tree have the and the right binary tree have the p and the q value. It means root is the lowest common ancestor. Right. And last case is if the last case is if both the node lies either in the left subtree or the right subtree. If left part is null, return right, else return left. So if return if left is equal to null, return right, else return left. So our coding part is done. Now let's try to run our test case. We are getting some compile time error.
We're done here with.
Like, okay, we need to add back is here also. Okay, so our test case is working. Now let's submit the solution. Yeah, so our solution is also working. And thanks for joining the session. Let's meet tomorrow.